Have you ever wondered what 575 tons of garbage looks like? This is how much Wheelabrator Gloucester, a waste management company in Westville, New Jersey, processes every day. Only by employing certain concepts of operations management can the company keep its $300 million plant profitable. Even though the plant uses everything from forecasting to facility layout, our focus will include statistical quality control data and scheduling techniques. Dump trucks unload garbage into an area where a crane stacks the garbage into an organized column. The crane drops loads of garbage into shafts where ferrous metals are separated and recycled. As the boilers burn, the resulting steam is sent to giant turbines that generate electricity, while the environmentally hazardous carbon dioxide gases are separated and cleaned. The carbon footprint of Wheelabrator's waste processing plant is actually negative. Our environment, as it turns out, is better off at the end of this process than it was at the beginning of it. An annual maintenance shutdown is planned 6 months in advance. Each boiler requires 7 days of complete shutdown in order to fully repair and maintain. Of a $3 million maintenance and repair budget, $1.8 million is devoted entirely to this shutdown. Let's take a look at how Wheelabrator applies two aspects of operations management to ensure the plant runs smoothly. Statistical process control, or SPC, is the application of statistical methods to the monitoring and control of a process to ensure that it's operating at its full potential while producing a conforming product. SPC involves inspecting a random sample of the output from a process and deciding whether the process is producing products with characteristics that fall within a predetermined range. One of the most critical SPC tools is the control chart. The control chart is a graph that shows whether a sample of data falls within the common or normal range of variation. A process is out of control when a plot of data reveals that one or more samples falls outside the control limits. Plant manager Mike Kissel describes how he uses SPC to capture the data for the boilers and how he identifies the data that may be a problem.
My name is Mike Kissel. I'm the plant manager of Wheelabrator Gloucester. Wheelabrator is a waste management-owned company located in Westville, New Jersey. We're a waste-to-energy power plant servicing the waste disposal needs of Gloucester County, as well as creating clean, renewable energy for the county. Waste delivery vehicles deliver the waste to us on a daily basis. They come across the scale, we weigh them in, they take the waste up to the floor, it's then dumped. Our loader operator will inspect the load to make sure there's no non-processable waste. It's then pushed into the refuse storage pit, and our crane operators will manage that waste and feed it into the units. We have 2 refuse fire boilers which combust the waste at about 2,000 degrees. That heat then boils steam and turns a turbine. That turbine generates 14 megawatts an hour of clean, renewable energy and is sent out onto the grid for purchase by the end user. The ash from the process is treated and sent to the local landfill for safe disposal. We also remove ferrous and non-ferrous metals for recycling. We're a very clean, renewable system. We're considered a negative carbon footprint because of the fact that we take the waste and instead of disposing of it at a landfill, which generates carbon emissions, we'll process it here on site and create green energy out of it. 14 megawatts will power roughly 14,000 homes.
We use statistical process control. We use a system called Tabware, which tracks our maintenance and cost spending for all of our equipment in the plant. We're able to trend and identify failure points in all of our equipment to make sure we can properly prevent any catastrophic failures.
Due to the fact that a failure of the ball bearings in a certain machinery would result in a shutdown of the entire plant, Wheelabrator tolerates only 2 standard deviations from the mean of the normal variation, which captures 95.44% of the normal variation.
In the example of the ball bearings, our process fans have bearings on each end, and we utilize a company to come out and take vibration readings on a quarterly basis. Those readings are then trended in a database, and we can watch for any kind of noise that's emitted from the bearings, which will indicate failure. We'll schedule a replacement on those bearings prior to failure to ensure we don't lose any downtime.
As you can see, around August of 2009, the vibrations reached 0.47 mils, With 1 mil being 1,000th of an inch, the ball bearings began falling outside the upper control limit and needed to be replaced. Once the problem is identified, deciding on the solution is the most important step in the process. Mike discusses what steps are taken from here.
We'll focus on the case of the bearing again. Once we see a bearing is showing signs of failure, we'll take the unit down during a scheduled outage. We'll identify the part needed. We'll schedule the work, and we'll see if we have the resources in-house to make the repair. Depending on the type of repair and how much time it's going to take, we'll either use a contractor or do it in-house.
Statistical quality control is crucial to Wheelabrator's operations. There's another application of operations management that is equally important to Wheelabrator: scheduling. Wheelabrator uses a combination of scheduling rules. Wheelabrator's operation is high volume and continuous. High volume operations are capital intensive and rely mainly on equipment, which makes maintenance and repair costly. For example, Wheelabrator generates about $1,000 of revenue per hour. Wheelabrator has developed a highly efficient schedule for its annual plant shutdown in order to minimize lost revenue. In order to avoid an unplanned shutdown, Wheelabrator must carefully prioritize equipment repairs while enabling the plant to continue running at a minimum level even during the planned shutdown.
We shut down sections at a time in order to keep the facility operating smoothly and to keep the trash volume moving in. We'll shut down one unit at a time for maintenance. We also power ourselves in-house, so this will keep us from buying power off the grid. We utilize refuse as our fuel to make steam. In that process, we burn the refuse, which in turn makes steam, which then turns a turbine, which makes electricity. When we bring one unit down, we'll generate less steam. However, we make a little bit of electricity, enough to power up all the equipment in-house and sell a little bit.
Let's see how Wheelabrator prioritizes their equipment repair schedule by utilizing a combination of scheduling rules.
When we shut a unit down, we'll focus on the boiler first. That's the most important piece of equipment. From there, we'll utilize past data from previous outages and shutdowns to determine what kind of tubes we're going to replace inside the unit. We take UT readings, or ultra thickness readings, on the tubes to see how thin they are and determine if they're going to fail or not. From that, we'll decide if we're going to make replacements or not. We then move on to our other process equipment to include process fans, external pumps, and air compressors to ensure that they will not cause us any downtime as well. We'll go for the most important pieces of equipment first, anything that's going to take us offline, and whatever's in the most disrepair from our vibration readings and other data. We want to make sure that we don't have any forced failures or forced shutdowns due to external equipment. So we'll make sure all the most important fans are taken care of first.
As Mike mentioned, Wheelabrator uses a combination of priority rules to schedule the sequence of their repairs. The first priority is the boiler repair, because this is the most important piece of equipment in their operations. Often companies must prioritize their operations based on constraints. In Wheelabrator's case, the boiler has a seniority constraint because the rest of the process depends on its proper functioning. Therefore, Wheelabrator must make it the highest priority. After the boiler repairs are completed, Wheelabrator uses earliest due date to prioritize the rest of the repair sequence. In this situation, earliest due date is defined as the anticipated date of failure for each piece of equipment.
About 20 years ago, before I started here, scheduling outages was very difficult. We ended up having some bottlenecks with scheduling the equipment to be done. The boiler work would be complete, but the fans wouldn't be ready yet, or vice versa, where the fans would be complete, but the boiler wasn't quite done. During that time, over the 20 years, we've taken that experience we have and we rely heavily on our contractors to ensure we properly plan an outage. It takes about 6 months to plan a smooth run outage.
Statistical quality control and scheduling are two applications of operations management that are crucial to Wheelabrator's continuous operations. If Wheelabrator's plant were to shut down due to inefficient operations, what would happen to that 575 tons of garbage? Due to the effective use of statistical quality control methods and proper repair by the operations team at Wheelabrator, we can all rest assured that our waste is being efficiently converted into clean energy. Wheelabrator's continuous flow of operations ensures that the garbage we place on our curb one day will be used to produce electricity to light our homes the next.